Hello everyone, I am Sagar Kumar. My student ID 36094816, and today I am walking you through my ICT 171 Cloud Server project. The main goal here was to get away from the local testing environments and actually deploy a live production ready web application in the cloud. I set up the whole backend stack from scratch, hosting an Ubuntu server, EC2, configuring Apache and pointing my custom pop-up domain onto it, and securing everything with HTTPS using Cardboard. I also added some client-side JavaScript to keep the front-end interactive functionality. So in this video, I'll show you the live site in the action, jump into my AWS and DNS configurations, and walk through the exact steps I took to get everything running. So right here you are looking at my live website at ytcreator.xyz. First thing you will notice here in the address bar is the padlock icon that tells the connection is completely secure. If I click on it, you can see the SSL certificate issued by Let's Encrypt. That means any data sent between a user and my server is encrypted. Now looking at the page itself, I didn't want to just be a plain static text. I added two custom JavaScript features. First right here you can see the dynamic timestamp. Every time someone loads or refreshes this uh, page, JavaScript grabs the exact current time from the user systems and renders it live on the screen. Second, I built an interactive click count. When I hit the right click button, a custom script updates the button count on the fly without needing to reload the page. And it's a simple feature, but it satisfies our client side scripting requirement and proves the page is dynamic. Now, now we have to move. Alright, let's talk about where the site actually lives. It is hosted on Amazon EC2. Amazon EC2 web server. Using EC2 has on my AWS dashboard. You can see my instance named Sagar web server, and I went with an Ubuntu server running 3 micro instance, and my parents type in AWS give me a global public IP address 13.60.58.95, which is a direct front door to my virtual machine. Now a super important step was making sure the server was safe while still allowing web traffic, so I set up a custom security group. Think of it like a digital security guard. If you look down here at my security groups inbound rules, you will see a selectively open just 3 specific posts to keep the instance secure while letting web traffic through. First, right here on port 80, that handles standard HTTP traffic so the web server can deliver basic web pages to visitors. Next, we have port 22, which is for SSH. This is what allowed me to jump into the server's command in line directly from my terminal to configure everything. And finally, port 443 at the bottom, which handles encrypted HTTPS connections. We need this open so browser can talk to our server securely over SSL once Cardboard is configured. By keeping only these 3 ports open and blocking everything else, the server stays accessible to the web without leaving unnecessary backdoors. Once my AWS instance was up and running, I jumped into my terminal and SSH into the server using my private key. The very first thing I did was run sudo apt update and upgrade to get all these latest patches. After that, I installed the Apache to web server I enable Apache to run automatically whenever the server boots up, and then I wrote my custom website code directly into HTML index.html. I used standard HTML5 for structure, added custom CSS styles to center everything and gave it a clean and layout, and wrote the JavaScript functions for the timestamps and button counter. Here you can see DNS configuration. Nobody wants to remember a row IP address like 13.60.58.95 to open a website, so I bought the domain ytcreatorhub.xyz on Porkbun. To link my domain name directly to AWS server, I have to configure DNS A records here in Porkbun control panels. As you can see on the screen, I set up two A records, one for ytcreatorhub.xyz and another for www.ytcreatorhub.xyz. Both of these records point directly to my server IP address 13.60.58.95. I set the TTL time to live to 600 seconds so DNS servers update quickly. Now whenever anyone types my domain name into their uh, browser, Popcorn knows exactly which AWS server to send to. At this point the domain worked, but browsers would flag it as non-secure because it was running on basic HTTP. To fix that, I installed an SSL TLS certificate using cardboard and Let's Encrypt. In my server terminal, I installed cardboard and ran the command to issue certificates for both ytcreatorhub.xyz and www.ytcreatorhub.xyz. Cardboard verified that I own the domain and it was generated the encryption keys and automatically update my Apache and it automatically update my Apache configuration files. I also set up automatic HTTPS to HTTPS redirect. That means if someone tries to visit the old HTTP version, my server automatically pushes them over the secure HTTP versions. Lastly, I ran a dry run test command like sudo cardboard renew dry run to make sure the SSL certificates will renew automatically in the background without any manual work from me. Finally, here is my projected expiry on GitHub under 171 Cloud Server project documentation. My README AMD file acts as a full documentation for the entire project, includes my student details, Sagar Kumar, student ID along with my server IP, domain link, and step-by-step setup commands, DNS tables, full source code, and a weekly progress log detailing how the project come together over 3 weeks. That wraps up my presentation. Everything is live, secure, fully documented, and running in the cloud. Thanks for watching my video. Thank you.